Welcome back. Problem 12-14. So statement is the simply supported shaft has a moment of inertia of 2I for region BC and moment of inertia I for region AB and CD. Determine the maximum deflection of shaft due to load P. So you can see this is the shaft, this BC region having in moment of inertia 2I, and for AB and CD we have moment of inertia I, and there is a point load at the mid of this shaft. So due to this load the beam will deflect or bend like this. So this will be the maximum deflection. This will be the maximum deflection. So we have to find this maximum deflection. So let's start with the solution. So we know that elastic curve and slope, elastic curve and slope can be found by using this formula, which is EI into EI into d square V over dx square is equal to moment. Clear? Where E is modulus of elasticity, I is moment of inertia, V is deflection, and M is moment. So for this, when we remove this support at point A, so there will be a reaction force. Let this is RA, and if we remove support at point D, so there will be a reaction force, and this is RD. So we'll find this RA and RD by using equation of equilibrium. So first equation of equilibrium is that sum of all moment about point D is equal to 0 and taking the counterclockwise moment as positive. So about this point, one moment is P into perpendicular distance is this one, which is L by 2, and that is equal to L by 4 plus L by 4. Clear? And this is producing counterclockwise movement, so it will be positive. So I will write P into L by 2. The second movement that is produced due to this RA force and perpendicular distance is this total L, and this is producing clockwise, so it will be negative. So I will write minus RA into L is equal to 0. So from here you will get RA into L is equal to P into L by 2, and this RA will be equal to P divided by 2. Now you have this RA, so you can find RD by using another equilibrium condition, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So RA, which is equal to P by 2, is upward, so it will be positive, minus P plus RD is equal to 0. So from here you will get RD will be also equal to P divided by 2. Now we'll move toward our main aim, that we have to find the deflection. So for that, what we will do is that we will take one coordinate, which is x1, clear, and the second coordinate, which will be equal to x2. x1, x2 will be like this one. So when we cut the beam at x1 and draw the free body diagram, so it will be like this. Let me draw it. This is your point A, where you have RA, which is equal to P divided by 2. This distance is x1, where we cut the section. So when you cut the beam, there will be a shear force V and there will be a moment M. Let this point is 1, so it will be M1 and V1. So we are interested to find out the moment, reaction moment at this point. So what we will do is that sum of all moment about point 1 is equal to 0 and taking the counterclockwise moment as positive. So about this point 1, one moment is P by 2 into perpendicular distance is x1, and that is clockwise, so it will be negative. The second one is this reaction moment, which is counterclockwise, so their sum must be equal to 0. So I will write M1 minus P by 2 into x1 is equal to 0. So from here you will get M1 is equal to P by 2 x1. So this is for coordinate x1. I will write for coordinate x1. Now what we will do is that we will take for coordinate x2, for coordinate x2. So when you cut the beam over here and draw the free body diagram, so it will be like this is the smallest shaft and this is the larger diameter shaft. So here you have RA, which is equal to P by 2. Now total distance where we cut the beam is x by 2, and this is your point 2. So there will be a shear force which is V2 and there will be a moment M2. Okay, we will find this M2 by using equation of equilibrium, which is sum of all moment about point 2 is equal to 0 and taking the counterclockwise moment as positive. So about point 2, one moment is P by 2 into perpendicular distance is x2. This is corrected, this is x2. So x2 divided by 2. So P by 2 into this is x2, not x by 2. Okay, P by 2 into x2 minus plus m2 is equal to 0. So here again we will get m2 will be equal to P by 2 x2. Now this is the equation of moment for coordinate x2. So we will apply for coordinate x1. For x1 we have equation EI into d square v over dx1 square is equal to m1. Clear? And m1 is equal to P by 2 times x1. If you integrate it once, so you will get EI into dv over dx1. So this will be dv1 because due to coordinate x1. So dv1 over dx1 will be equal to px1 square over 2 plus c1. Now again integrate it. We will get EI into V1 is equal to P1 x1 cube over this will be x power 3 divided by 2 into 6. Okay, if we take the integration of this term P by 2 into x1, this will be P1 x1 square over 4, not 2. Okay, so make this correction. Again, if you integrate this term, so it will be P1 x cube over 12. 3 into 4, which is 12, plus C1x plus C2. Now for coordinate x2 we have EI into d square v2 over dx square is equal to m2, and m2 is P by 2 x2. Here for coordinate x2 we have BC region. Clear? And it is given that BC region having moment of inertia 2I. So here we will write 2 times EI. Okay, now integrate it once. Integrate it. So you will get 2EI into dv2 over dx2 is equal to px2 square over 4 plus c3. Again integrate. So you will get 2 times EI into V2 is equal to px2 cube over 12 plus C3 x2 plus C4. Okay, so let this equation is equation number 1, this is equation number 2, this is your equation number 3, and this is your equation number 4. So what we will do is that you can see C1, C2, C3 and C4 are unknown constant of integration. So you will find them by using boundary condition. So now we will move toward boundary condition and we will check which are the boundary conditions. So first boundary condition, I will first write it. The first boundary condition is that x1 is equal to 0. At x1 is equal to 0, we have v1 is equal to 0. Let me show you over here. So you can see at here x1 is equal to 0, there is a support, so deflection at this point will be 0, because we have already told you that this beam will deflect like this. Clear? So here v1 will be equal to 0. So we'll move toward, now if you can see that we have v1 equation is this one. This 2 number is for v1. So put in equation number 2. So when you put x is equal to 0, so this term will be 0, this term will be 0, and v1 is equal to 0. It means c2 will be equal to 0. So you will get c2 will be equal to 0. Now the second boundary condition is that this was your first boundary condition. Second boundary condition is that at x is at x2 is equal to L by 2, we have dv2 over dx2 will be equal to 0. Okay, so you can see this is L, x2 is equal to L by 2. So here if we take tangent to this curve, so here you will be having dv2 slope will be equal to 0. So the slope equation is this equation number 3 for x2 coordinate. So put x2 is equal to L by 2 and dv2 over dx2 is equal to 0 in equation number 3. So when you put it, so you will get 2 times ei into 0 is equal to p into L by 2 whole square divided by 4 plus C3. Okay, so we will get 0 is equal to PL square over 16 plus C3. So C3 will be equal to minus PL square over 16. So this is your C3. Now what we will do is that we will apply the third boundary condition. So third boundary condition is that we will use continuity equation. So continuity equation means that at x is equal, x1 is equal to x2 is equal to L by 2, we have dv1 over dx1 is equal to dv2 over dx2. At x is equal to L by 2, not L by 2, L by 4. Because at x is equal to L by 2, dv1 over dx1 is equal to dv2 over dx2 will be equal to 0. So we will take it at x is L by 4. So let me show you here x1 is equal to L by 4 and x2 is also equal to L by 4. So if you take tangent to this curve, so here you will be having dv1, I will write it over here, dv1 slope at due to coordinate x1 is equal to slope at due to coordinate x2. So what we will do is that we will put x is equal to L1, x1 is equal to L by 4 in this equation 1 and in this equation number 3, and we will equate them. So let equate them. So we will be having, you can see that if you take x is equal to, so the first equation 1 will become equal to EI into dv1 over dx1 will be equal to PL square over 16 times 4 plus C1. This will be the equation number 1, and equation 2 will be equal to 2EI into dv2 over dx2 is equal to P into L square over 16 multiplied by 4 plus C3. Now you have to equate dv1 is equal to dv2. So again, from here you will get PL square over 64 plus C1 is equal to PL square over 128 minus 1 over 2. C3 is this value, so you can put the value of C3 minus PL square over 16. Because we have 2 over here, so if you, this is equal to, this is this term is this one, and 2 will be divided on this side, so this will be this. So when you solve this, you will get C1 will be equal to minus 5 PL square over 128. So you have now C1, C2 and C3. So we will move toward C4 to find C4. So for C4 we have fourth boundary condition, and the fourth boundary condition is that x1 is equal to x2 is equal to L by 4. We have v1 is equal to v2, and we will put them in equation 2 and 4 and equate them. So let me first show you at x is equal to this boundary condition. You can see that this deflection v1 is equal to v2. So we will put it in this equation number 2 and equation number 4, and we will equate them. So note down these equations. So at x1 is equal to L by 4 in equation number 3. So when you put it in equation number 2, so you will get EI into V1 is equal to PX. Instant of x1, it will be L by 4. So PL cube over PL cube over 4 cube. 4 cube will be 64 multiplied by 12 plus C1x. So C1 into L by 4, and C1 is already we have calculated or not. So C2 was calculated, C3 was calculated, and C1 was also calculated. So C1 was minus 5 PL square over 128 into x. So x is L by 4. So L by 4 plus C2. Clear? C2. And we know the C2 value. C2 is, again, this value is 0. You can check it. So you will get this equation. Now at x1 is x2 is equal to L by 4. Put in equation number 4. So you will get 2 times EI into V1 is equal to, V2 is equal to P times x2 square, x2 cube. So x2 cube is again L cube over 64 multiplied by 12 plus C3 is, again, C3 is minus PL cube over 16 x2 is L by 4 plus C4, which is not known. Okay, so now you have to equate this equation and this equation. So this equation, after equating, you will get it PL cube over 768 minus 5P L square over 128 multiplied by L by 4 is equal to 2 will be divided on both sides. So here we will get PL cube over 1536 minus 1 over 2 PL cube over 16 multiplied by L by 4 plus 1 over 2 C4. So when you solve this, you will get C4 will be equal to minus PL cube over 384. Now we have C1, C2, C3 and C4. So we are interested to find out the deflection at mid, which is equal to V2. So we will put a value of C3 and C4 in this equation number 4 to get the equation of deflection. So put C3 and C4 in equation 4. So you will get 2 times EI into V2 is equal to, let me check the equation, px2 cube over 12 plus C3 into x2. C3 is, where is C3? So C3 is this one minus PL square over 16. You can see this one minus PL cube over 16. Let me check it again. Minus PL square over 16 into x2 plus C4. So C4 is minus PL cube over 384. So if you are interested in V2. So V2 will be equal to 1 over 2 times EI into px2 cube over 12 minus PL square x2 over 16 minus PL cube over 384. So this is equation of deflection due to coordinate x2. Now at x, as we are given to find out deflection at mid, so x2 is equal to L by 2. So we will put this as equation A. So put in equation A. Okay, so when you put in equation A, so V2 will be equal to 1 over 2 EI, and we will be having PL cube over 8 multiplied by 12 minus PL cube over 16 by 2, which is 32, minus PL cube over 384. So when you simplify it, you will get V max is equal to V2 at x is 2 is equal to L by 2 will be equal to P divided by 768 EI. You have to take the LCM of this and then you have to solve this. Very easy. You can do it. And the remaining term will be equal to 32. Okay. You will get when you take the LCM and put this is also x is V max at x is 2 is equal to L by 2. So you will get the final result will be minus 3p L cube over 256 E times I. Or it means negative sign, so negative sign mean that the deflection will be this one and it will be downward. So now if you know the value of P, total length L, I and E, so you can calculate this V max, maximum deflection. And that was all about this problem 12-14 which I have solved. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.